Hi guys, welcome back. We're in Unit 10, Day 2 notes. This time we're going to be focusing on exponential decay. Let's recap a little bit on the growth and then swing over to the decay type problem. So, filling this out again, I know you have your notes from yesterday. I'm going to recap, and I'm pretty sure I didn't write the formula yesterday, so let's put these down this time. If it's a growth problem, growth means something is increasing, getting bigger, it's growing, larger, something like that. And I know I don't think I wrote this yesterday, but it looks like y equals j, and then 1 plus r to the power. Really, what you hold this on here, that plus sign. If there's that little plus sign in there, that is your growth plus getting bigger equation. And then we did this yesterday, but your graph, the growth, is getting bigger, is rising up, looks something like that. Well, what we're going to focus on today is the decay part. Decay would mean that something is decreasing, going down, getting smaller, shrinking, something like that. Your formula is almost going to be identical, except instead of a plus sign, you have that little minus sign, right? It's getting smaller, it's decreasing, it's going down. So we have that minus sign, and then the graph again, just so you know what it looks like. For decrease, decay looks something like that, going downward. Okay. So the pieces in these formulas, the A, initial value, that's all the same. R is the rate, C is the time. All of that is the same. One's a plus, one's a minus. So just pay close attention. That's this really small detail. So we're going to focus on decay examples today. Same setup as yesterday. We're going to do the left side example first. Kind of, sort of similar in the way that we're going to rewrite some of these things. So it gives you, let me read the instructions. Given the following equation, fill in the blank, and then sketch the graph. So it gives you the function. We're going to fill those in. We're going to make the graph for that final step. So it gives you f of x is equal to 4 times 0.82 raised to the x power. When we rewrite this, we want to make it look like what we have written up. I'm going to rewrite this as y. This f of x for a second, I gotta figure that out. I know I need the 1 in there, and I know it's a decay problem, so it's gonna have a minus. So what you can do in your head, you can do 1 minus 0.82, because 0.82 is what you gave you. You can do that quick in your head, and you get 0.18. That means 0.18 is what goes in the parentheses there. And I talked about this yesterday, but let me highlight. Those two yellow pieces aren't different. 0.82 is the same thing as if I were to subtract this other piece right here. Not that I completely changed the numbers, I just rewrote it. So that's my rewrite. My next piece is the initial value. The initial value was the number from the front. So this one has a 4. Just a random side note, if there isn't anything in the front there, we assume it's a 1. Okay, but this one has a 4. So that goes there, that's our initial value. Some of you were writing this yesterday, or maybe in class you saw it as a coordinate 0, 4. That might help some of you. The next one is asking, was this growth or decay? Well, we've already talked about this, but you could look at what you started with in the beginning, 0.82, and compare it to the number 1. This is smaller. If it's smaller, then we have a decay problem. I'm going to back up, rewrite this down here. 0.82 is less than 1, so it's decay. So then it says, well, what is the decay factor? The decay factor, I'm going to do my blue arrow again, is whatever you used in your rewrite. So that decay factor is 0.18. So then it says, well, what is the percentage? I take 0.18, I loop it over twice, make it into a percentage. It's 18% decrease. This time it's a decrease because I'm dealing with a decay problem. So 18% decrease. So then when I go to graphic, I want to start with my initial value. My initial value is telling me that it's starting up at 4, but then it's a decrease. So it's going the other direction from yesterday. So it's starting up at 4, but my graph is connecting, going the other way. Okay, let's look at this next one. right next to it, problem B. G of x is equal to 0.65 times 0.37 raised to the x. I'm going to rewrite this. Pretty much everything is the same except for the piece in parentheses. I need there to be a 1 minus because it's a decay problem. If you're getting stuck on that, or you can't quite figure it out, you can take 1 minus 0.37 and find that difference, and you get 0.63. That 0.63 is the remaining piece in the parentheses. The initial growth is the number from the front, so that is 0.65, or again, some of you saw it as a coordinate, so 0, 0.65. It's asking, well, is this growth or is it decay? Well, look at the number they gave you in the very beginning. 0.37 is less than the number 1, so that's telling you that this is a decay problem. I'm going to write that right next to it. 0.37 is less than 1, so that means it's decay. The decay factor is whatever you used in the rewrite. So in the rewrite, we use 0.63. So that's your decay factor. How do you turn that to a percentage? You take that decimal, you move it 2 times over, you get 63%, and then label this as a decrease because this is a decay. So it's going down, decreasing at a rate of 63%. So it's really kind of going down fast. I start my graph with the initial value. My initial value is at 0.65, right about there. It is decreasing. My decreasing looks something like that. Again, it's a rough sketch. We got to put our initial value on there and then make the shape. Okay, if I went too fast on those first ones, pause it, go back, rewind it, watch them again. Now we're getting to the word problems. Example 1. You buy a new car for $24,000. The value of the car decreases by 16% each year. You buy the car, but every year you drive it, its wear and tear is decreasing in value. Write an exponential decay model for the value of this car. It's just a model, okay? Just a reminder, I know we have it on the front, but here's my formula. A is for initial value or initial amount. R is for the rate, and I'm going to put a star by that one because it needs to be in decimals when you put it in. So I'm going to say decimal. And then T is for time. Just a quick reminder. I'm going to go through what they gave me and kind of sift through it. You buy a car for $24,000. That's how much you paid for it initially, right up front. So that's your A. The value of the car decreases, so this is good, it's a decrease, a decay, by 16% each year. I need to take that 16%, I need to work backwards, I need to get it back to a decimal. That would be 0.16. That's your rate. What is the exponential decay for the model of the car, or decay model for the value of the car? So we don't know T, we just want a model. When I go to plug in, I'm going to have Y equals, instead of an A, I put 24,000. Instead of the R, I put 0.16. And I leave the T there, I leave the Y there. This is my model. This person can have this car for 20 years. So they could plug in 20 for T, type it in their calculator, and get how much the car is worth. It depends. Maybe they only have the car for 3 years and then they want to sell it. So they put time in for 3 years, see what they could sell it for. Okay. Your mama's car is now worth $5,000. You bought it 6 years ago and you expected it to depreciate or 15% each year. Write an exponential decay equation regarding the situation. So again, talking about cars, it's going down in value. A couple different numbers here, so let's plug it in. I'm going to rewrite my equation. We have your mom's car is now worth $5,000. So after all this time she had this car, it's now worth $5,000. That's why. That's how much it's worth now, like the final. bought the car 6 years ago. 6 years ago would be T, time. You're expecting it to depreciate, decrease, so decay at 50% each year. So I need to take that work. And I'm at 0.15 decreasing. What is the exponential decay equation for this situation? I know some different pieces, so let's plug it in. I know y. Y is 5,000. A, no clue. I have 1 minus 0.15. I need the R. And actually, I know T this time. I can plug a little bit. Okay, write an exponential decay equation regarding this situation. Right now, I kind of got a mess. It doesn't look like all of our other answers. So what I'm going to do is work through this and solve for my A variable. Notice I have everything else. What I'm going to do is take this piece by piece. I'm going to do inside the parentheses first. So 5,000 minus 5,000 equals A. And then subtract those minuses to get 0.85 power. And in my calculator, I'm going to take 0.85 raised to the 6th power. Let the calculator do that for you. And I get A, and then when I plug that in, I get 0.38. Running out of space. I'm going to move it up here. I have 5,000 is equal to A times 0.38. Again, I use my calculator. I want to get A by itself, because you're doing last highlighting it. I want to get A by itself, so I'm going to divide both sides by 0.38. And when I divide those, I will get A is equal to 13.157. Okay, awesome. Well, what does that mean? That means for my exponential decay equation, I want to plug that in. So I'll have y is equal to A, which we now just figured out is 13.157, and then times 1 minus 0.15 to the t power. So it gave us some specifics. We had to use those specifics to come up with the model. And now we have that model. Okay, much harder. We haven't seen a problem like that. It gave us some different pieces. We used the same formula. We plugged in. We found the missing piece. We then plugged it in to get our final answer. Okay, let's see. One more. This one should be quicker. Example 4. Carlos bought a new boat for $32,000 and expects it to depreciate, again, fancy word here for decrease, at a rate of 15% each year. Write a mathematical model that represents the value of the boat. Okay, well, here's our equation. Y equals A times 1 minus R to the power through this. He buys the boat, $32,000. That's how much he paid. That's the initial value, how much he had to buy the boat for. It is decreasing, going down at a rate of 15%. That 15% down decimal 1.5. Okay, plug in what I know. I have y equals A is 32,000. 1 minus R, we just figured out R is 0.15. And then to the t power, because it's saying, just write a model. Here's my model. So somebody could be like, oh, this boat, it looks awesome. And Charles was like, oh, well, I've had it for 6 years. I wonder what the value is. So he could plug a 6 in for t, figure out how much the boat is worth, and see if it is a good value, if he'd get any money on it, if he wants to sell it. So those are the two pieces. There's my model. If I went too fast, you're confused, you're not quite sure on some of the words or some of the phrases, pause the video, go back, watch a certain section. Make sure you're giving your homework a try, because there's lots of practice examples on there as well.